Imagine looking up at the night sky, seeing countless stars, each a potential sun, many with planets. The vastness above us is both humbling and awe-inspiring, a silent ocean of light stretching farther than our minds can truly grasp. For ages, humanity has asked, are we alone? This question has echoed through generations, whispered around campfires, pondered by philosophers, and written into the very fabric of our myths and stories. The universe has seemed silent, but maybe we just weren't listening the right way. Perhaps our technology was too primitive or our expectations too narrow to catch the subtle hints drifting through the cosmic dark. What if, across the vastness of space, a faint whisper has been traveling, waiting for us to finally hear it? A message not in words, but in the language of light and chemistry, encoded in the very fabric of distant worlds. Today, August 7th, 2025, that whisper has become a clear signal. After decades of searching, the cosmos has finally answered back, and the world holds its breath. The search for extraterrestrial life has driven our exploration of Mars, the moons of Jupiter and Saturn, and our relentless scanning of the cosmos. Each mission, each discovery, has been a step toward understanding our place in the universe. We've sent messages into space, built massive radio telescopes, and calculated the odds with equations like the Drake equation. We've wondered if anyone out there might be listening, or if we are just a lonely spark in the dark. But until now, it was all theory, no hard evidence. The silence was deafening, and hope sometimes faded in the face of the unknown. The silence led to theories like the Great Filter, maybe life is rare, or intelligent life destroys itself, or the universe is just too vast for signals to cross. Some wondered if we were simply too late or too early to join the cosmic conversation. But science pushes boundaries, seeking real answers. Today, the narrative changes. The unknown becomes a little less mysterious, and our questions find their first real response. The James Webb Space Telescope, our most powerful eye on the universe, has given us the first concrete evidence that we are not alone. Its instruments have peered deeper than ever before, revealing secrets hidden in the starlight. It's not a radio signal or an alien artifact. There are no messages in binary, no mysterious objects drifting through space. It's something more fundamental, the chemical fingerprint of a living world imprinted on the light of a distant star. Molecules that shouldn't exist without life, written in the spectrum like a cosmic signature. The silence has been broken. The universe, once thought indifferent, has revealed a sign of life beyond Earth. We are finally beginning to understand the cosmic conversation. Each discovery is a new word, a new phrase, in a language we are just starting to learn. The universe is speaking, and now we can listen. Our journey has just begun, and the cosmos awaits our reply. To truly grasp the magnitude of this discovery, we first need to understand the James Webb Space Telescope, often called JWST. This remarkable observatory represents the next giant leap in humanity's quest to explore the cosmos, building on decades of innovation and curiosity. Launched in December 2021 after years of anticipation, JWST now sits nearly 1 million miles from Earth, far beyond the Moon's orbit. It's carefully positioned at the L2 point, a gravitationally stable spot, where it remains shielded from the sun by a massive sun shield, allowing its sensitive instruments to stay cold and function optimally. Unlike the legendary Hubble Space Telescope, which observes mostly in visible and ultraviolet light, JWST is designed to see the universe in infrared. This ability is crucial for peering through thick clouds of cosmic dust, and for observing the faint ancient light from the earliest galaxies that formed after the Big Bang. Its gold-coated segmented primary mirror spans over 6.5 meters across, more than twice the size of Hubble's. This enormous mirror collects more light than any previous space telescope, enabling JWST to detect incredibly faint objects at the farthest reaches of the universe. In essence, JWST acts as a cosmic time machine, allowing us to look back over 13.5 billion years, almost to the very dawn of the universe itself. Its ambitious mission is to study the early universe, watch galaxies and stars as they form and evolve, and perhaps most excitingly, analyze the atmospheres of distant exoplanets for signs of habitability. By examining starlight as it passes through a planet's atmosphere, JWST can detect the presence of water vapor, methane, carbon dioxide, and other molecules, chemical fingerprints that could hint at the possibility of life, or at least the conditions necessary for it. Today's historic announcement is made possible by this extraordinary capability, opening a new chapter in our search for life beyond Earth. JWST is truly our cosmic detective, tirelessly searching for clues hidden in the faint light from distant worlds and unraveling the mysteries of the universe. It's not just a telescope, it's our bridge to the unknown, connecting us to the vast, unexplored realms of space and time. And the most exciting part, JWST's journey is only beginning, with countless discoveries still waiting to be made. The focus of this discovery is exoplanet GJ1214b, nicknamed Xylos, orbiting a red dwarf just 48 light-years away. Xylos isn't new, it was found in 2009. But its true nature was hidden by a thick, hazy atmosphere. Previous telescopes couldn't see through the haze, leaving us with only guesses. Its size and mass suggested a water world, but we needed better data. Enter JWST. Using its near-infrared spectrograph, scientists observed Xylos during its transit, analyzing starlight filtered through its atmosphere. This painstaking process revealed the chemical composition below the haze. The results, published today, are revolutionary. JWST detected vast amounts of water vapor, more than any planet in our solar system. The water world hypothesis is confirmed, but there's more. JWST found a combination of gases that points not just to habitability, but to possible life. For the first time, we have evidence of a living world beyond our solar system. The cosmic curtain has lifted. Biosignatures are chemical clues that point to life. These are specific molecules or patterns in a planet's atmosphere that, based on our understanding, are most likely created by living organisms. Scientists search for these subtle hints, hoping to find evidence that life exists beyond Earth. On Earth, oxygen is a powerful biosignature, produced by photosynthesis. Plants, algae, and some bacteria release vast amounts of oxygen as they convert sunlight into energy, filling our atmosphere with this life-sustaining gas. Finding one biosignature is exciting. Finding several together is the holy grail. When multiple biosignatures appear side by side, it dramatically increases the likelihood that life is present, since it's much harder for non-living processes to create such a combination. On Xylos, JWST found the chemical equivalent of a house: water vapor, significant oxygen, and methane. These are the building blocks and byproducts of life as we know it, all detected in the planet's atmosphere. Oxygen levels are about 15%, close to Earth's 21%. This is a remarkable similarity, suggesting that Xylos could have an environment not too different from our own. Such high oxygen is hard to explain without biological photosynthesis, likely from oceanic life. The presence of vast oceans could mean that something similar to Earth's marine organisms is at work, releasing oxygen into the air. Methane is also present. On Earth, it's mostly produced by living organisms. Wetlands, microbes, and even some animals contribute to our planet's methane, making its presence on Xylos especially intriguing. Oxygen and methane together are highly reactive. They shouldn't coexist unless something is constantly making both. Their simultaneous presence suggests an active, ongoing process, likely biological in nature. The simplest explanation: life is at work. This is the most straightforward answer, given all the evidence. JWST also detected dimethyl sulfide, or DMS, a molecule produced almost exclusively by marine life on Earth. Its presence is a strong indicator of biological activity, especially in ocean environments. DMS gives the sea its smell and is rarely made by non-biological processes. Its detection on Xylos adds another layer to the growing evidence for life. This trifecta, oxygen, methane, DMS, forms a powerful, compelling case for a thriving biosphere. Each molecule alone is interesting, but together, they tell a story that's hard to ignore. It's a chemical symphony, echoing across light years. These signals are like music, carrying the message of life from a distant world to our own. For the first time, we're hearing the music of another living world. The implications are staggering, opening a new chapter in our search for life in the universe and forever changing our place in the cosmos. How do we know what's in Xylos' atmosphere? It's all in the spectrum. JWST captured starlight passing through Xylos' atmosphere during transit, creating a barcode of absorption lines. Each molecule absorbs light at specific wavelengths, leaving unique fingerprints. JWST's NIRSPEC instrument revealed massive water vapor absorption, confirming a water-rich atmosphere. Distinct lines for oxygen and methane stood out, so clear, the team double-checked for errors, but repeated observations confirmed the signals. The detection of dimethyl sulfide was trickier, but JWST's high resolution isolated its faint signature. Computer models matched the observed spectrum only when DMS was included. The statistical significance is 5 sigma, the gold standard in science. Every possible error was ruled out, not from the star, not from our solar system. Independent teams reviewed the data. The molecules are there. The evidence is robust and undeniable. The only debate left: what's making these chemicals? The simplest answer is life. The universe just handed us a smoking gun. Xylos forces us to rethink the habitable zone, the region where liquid water can exist. Traditionally, we looked for rocky planets at just the right distance from their stars. Xylos orbits close to a dim red dwarf, completing a year in just 1.6 Earth days. Such proximity usually means tidal locking, one side always in daylight, the other in darkness. This should create extreme temperatures and harsh conditions. But JWST's data shows Xylos has a thick, water-rich atmosphere that redistributes heat, moderating the climate. A deep global ocean helps regulate temperatures and shields life from radiation. This discovery shows that habitable worlds can exist in places we once dismissed. Red dwarfs are the most common stars. Now their planets are prime candidates for life. Xylos proves our search has only just begun. The universe is more welcoming than we imagined. Xylos isn't just another data point, it's a paradigm shift. For astrobiologists, it's the first real chance to study an alien biosphere. Xylos will reshape our models of planet formation, evolution, and habitability. It's a new archetype, a water world teeming with life. Philosophically, this changes everything. Knowing we're not alone redefines our place in the cosmos. It will inspire new missions, new telescopes, and a new era of exploration. The search for life is no longer theoretical, it's observational science. For decades, the Fermi paradox asked, if life is likely, where is everybody? Xylos doesn't solve the paradox, but it reframes it. Life may be common, but technological civilizations could be rare. Xylos is likely home to microbial or plant-like life, not radio-building aliens. The universe may be humming with life, just not the kind we expected. We've been listening for radio signals, but life speaks in chemistry. Xylos teaches us to broaden our search. The universe may have been talking all along, we just needed to learn its language. We stand at a historic crossroads. JWST has delivered compelling evidence of a biosphere on Xylos: oxygen, methane, and DMS. Together, they point to a living world. This discovery transforms the search for life from theory to observation. Xylos redefines what it means to be habitable and opens the galaxy to new possibilities. The silence was just the limit of our senses. Now we see the universe as a place of vibrant biology. The story is just beginning. How many more living worlds await discovery?